Welcome to Ask and Learn.
So now we'll work on problem 6 from chapter 6. In this problem, we're told that a certain quantum mechanical system has the energy levels shown in the accompanying diagram. So the energy levels, the energy diagram which were shown, I'll go ahead and put here. It looks something like this. Okay, let's start. So we have at the bottom n is equal to 1. A little higher we have n is equal to 2. And then even further up we have n is equal to 3. And then finally much higher we have n is equal to 4. And then energy is our scale here, with energy increasing as we go up. So the energy levels are indexed by a single quantum number, which is n. And then it asks us, as drawn, which quantum numbers are involved in the transition that requires the most energy. So this is part A. We can see that really n is equal to 1 should be at the bottom here. So we can see that we can just observe by the with our eyes to see which two quantum numbers have the greatest energy difference between them, from n is equal to 1 to 2 to 2 to 3 or 3 to 4. And we can see that if we go from n equals 3 to n equals 4, this is the greatest transition. The part B says which quantum numbers are involved in the transition that requires the least energy. And that transition would be n equals 1, n equals 2, because as you can tell, the smallest distance is between those two quantum numbers. And then part C, it says, based on the drawing, put the following in order of increasing wavelength of the light absorbed during the transition. So we're talking about absorption processes, and we want to put in order of increasing wavelength. In increasing wavelength, if the wavelength increases, that means the energy must decrease. So we want to put in order of the highest energy first and then decreasing from there. So we're given 3 transitions, n equals 1 to 2. 4 transitions. N equals 2 to 3, n equals 2 to 4, and n equals 1 to 3. So the greatest transition, the highest energy, or the smallest wavelength, is going to be n from 2 to 4. That's the greatest energy or the lowest wavelength transition. After that, the next greatest transition is from 1 to 3. All of these are absorption processes, so we're gaining energy. And then from there we have 2 to 3. And then 1 to 2 is our obvious choice for the smallest energy or greatest wavelength.